Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back. And today we're going to review another geometry topic that involves trigonometry. Okay, so let's just go ahead and jump right in. It says for sine, cosine, and tangent, remember SOHCAHTOA. So is SOH, CA is CAH, TOA is TOA. Now, that acronym basically tells you how to remember how to set up the ratios. For example, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Now, opposite, adjacent, and hypotenuse obviously come from triangles. And you have to know how to label these right triangles. Okay? So, if you watch my last video about the 45-45-90 and the 30-60-90, you should be somewhat familiar with labeling these, but it's going to be a little different now. So, because instead of like a leg or a short leg and a long leg, we're going to be labeling the legs with opposite or adjacent. Now, H is always hypotenuse. Hypotenuse doesn't change. So, let's go ahead and take a look at number 23. For example, the first thing I want to do is always label my hypotenuse. So 30 is the hypotenuse. It's going to always be the hypotenuse. Now, depending on what angle they're talking about is going to help me figure out what is opposite and what is adjacent. So for these first three, W is the angle that they're talking about. So if I need to label, I have to figure out what side is opposite of W. Well, 24 is opposite. So our opposite side, when we do this when we do these three for angle W, 24 will be the opposite, which means that 18 is the adjacent. Now I just follow the little formulas that we wrote up at the top. So for sine, once again, remember, is equal to opposite over hypotenuse. Well, opposite is 24. Hypotenuse is 30. Now, with any fractions, you need to always reduce them. 6 can go into both of these. So this is going to turn into 4, and this will be 5. So really, sine of angle W is 4/5. Okay? Now, cosine, once again, is adjacent over hypotenuse. Well, adjacent is 18. The hypotenuse is 30. Once again, simplify. Divide both of these by 6. That becomes 3/5. And now the last one. Tangent of W is simply the opposite over the adjacent. So the opposite here is 24. The adjacent is 18. Simplify. Both of these can be divided by 6. This becomes 4/3. All right. So we did the first angle, W. Now we can get rid of these markings. The hypotenuse is going to stay the same, but now that we're going to focus on X, okay? So when we focus on X, we have to figure out what side is opposite of angle X. Well, the side that's opposite angle X is 18. So now the 18 is the opposite, and the 24 is the adjacent. So let's go through. Once again, sine is opposite over hypotenuse. Well, opposite is 18. Hypotenuse remains as 30. And once again, we have to reduce. Divide both of those by 6. This becomes 3/5. The next one, cosine of X. Cosine is adjacent over hypotenuse. Well, adjacent is 24. Hypotenuse is 30. Simplify it. This becomes 4/5. And now the last one, tangent of X, is opposite over adjacent. So opposite is 18. Adjacent is 24. When we reduce this, this becomes 3/4. All right. So that's just a brief review of how to label your right triangles when you're using your trig functions, and then how to actually apply the trig functions. Now we need to go ahead and take a look at these answers down here. But the whole time, if at any time, because I'm going to be scrolling the screen during the video, so these formulas won't be present. So if you're watching and taking notes, make sure you have these written down so that way you can refer to them as I'm going through 24 through 32. Okay? All right. So first thing we want to do with all of these triangles is at least label the hypotenuse first of all. Okay? Hypotenuse, right? Hypotenuse, right? Hypotenuse, okay? Hypotenuse. Definitely want to get in the habit of knowing where the hypotenuse is for a right triangle. And remember, it's always opposite the right angle, okay? Now, in order for number 24, we always want to highlight the angle. Once we highlight the angle, and I'm going to use the blue highlighter. Once we highlight the angle, then we can determine what's opposite and what's adjacent. Okay? Let me rewrite that O. All right. Now, it says we're solving for X each time. Okay? So for this one, we have, they gave us and we look at the parts that they give us. We don't have any number for the adjacent, so we're not going to worry about the adjacent part, okay? The two things that they did give us, and I'm going to circle those in red, they gave us something for the opposite, and they gave us something for the hypotenuse. So those are the pieces that we're going to use. Now, if we remember, we go back up here, which one of our trig functions uses the opposite and the hypotenuse? That would be sine. So for this one, for this example here, we're going to be using sine is equal to opposite over hypotenuse. Now, sine of the angle. So we need to do sine of 31 degrees is equal to X over 15, okay? And we need to solve for X, all right? Now, in this case, X, in order to solve for X, we would simply have to multiply, okay? Multiply both sides by 15. So that really tells us that X is really equal to 15 times the sine of 31 degrees is equal to X, okay? Now we just need to figure out what X is equal to, okay? So what I'm gonna do real quick, I'm gonna rewrite all this with a smaller pen. So we know we're gonna use sine of the angle, and we'll use this to represent angle to theta, is equal to opposite over hypotenuse. Our theta, which is our angle measure, is 31 degrees. And that's equal to X over 15, okay? And remember what I said. In order to get the X by itself, we're going to have to multiply 15 on both sides, okay? Multiply 15 on both sides. So now we know that X is equal to 15 times sine of 31 degrees, okay? Now in the calculator, so for these, we will have to use a calculator because we want an answer, and they're asking us to round it to the nearest 10. So what I'm gonna do is pull open my calculator. Let's clear this, okay? So what we're gonna need to do first is I'm gonna put 15 times, and then I'm gonna put parentheses, and I have to type 31 And let me delete all this first. The very first thing you want to do if you're using some type of scientific calculator, make sure that it's already in degrees. See, my DEG, if I hit RAD, that's radians. We want it in degrees. So make sure your calculator is set up for degrees. And then I can go ahead and do 15 times, and I'm going to put parentheses. And then I want the sine of 31 degrees. Okay, and I'm going to close it. So the way to do that, you have to type 31 first and then hit sine. Some scientific calculators let you hit sine, and then it's going to be parentheses. You put the 31 inside. For that, depending on what type of calculator you're using, either ask your teacher to make sure that you're putting these in properly. So now that I've done that, 15 times the 31 sine of 31, I just hit equals, and that's going to be 7.7 because they want us to round it to the nearest tenth. So x is equal to 7.7. Okay, and that would be my answer there. All right, let's take a look at number 25. Once again, 25, after we label the hypotenuse, identify the angle. Okay, so that way we know how to identify what's opposite and what's adjacent. So opposite that angle is x, and then that means that 7 is the adjacent side. Now, to figure this out, we don't have anything for the hypotenuse. If you look where the hypotenuse is, there's nothing labeled there. Okay, there's nothing that they already gave us. But if we look at the opposite, they gave us x, and for the adjacent, they gave us 7. So we need to look at our trig formulas. The only trig formula that uses opposite and adjacent is tangent. So we're going to use tangent of theta is equal to opposite over adjacent. Theta in this case is 48. Okay, so tangent of 48 degrees, okay, is equal to x over 7. All right. Now, once again, in order to get this to solve for x for this one, we're going to have to multiply 7 on both sides. Okay, so x is equal to 7 times the tangent of 48. So now if I want to figure that out, first things first, I'm going to clear my calculator. I'm going to type in 7 times, then I'm going to hit parentheses. And I have to type the number that I want to take the tangent of. So 48, and then I have to hit tangent, and I'm going to close it, and then I'm going to hit the equal sign. Okay. Now, once again, they want us to round it to the nearest tenth. Our decimal, in case you're wondering, it says 7.77. Well, this is a number that's higher than 5, so that means I got to round that 7 up to an 8. So my decimal place is really going to be 7.8 to the nearest tenth, okay? And that's the value of x. All right, let's take a look at number 26. Once again, 26, we already labeled the hypotenuse, okay? So let's identify the angle, which is right here. Now we need to identify what's opposite that angle. So this blank side is opposite, which means that the 22 is adjacent, okay? So the angle, and now we got to look at our diagram. We have something for the hypotenuse, which is x, and we have something for the adjacent side, which is 22. The opposite side is blank, so we're not going to use the opposite. So we need to know which one of our trig functions do we use adjacent and hypotenuse. Well, that would be cosine. So this is going to be cosine of theta is equal to adjacent over the hypotenuse. Now, this is going to become cosine of theta, not theta, but in this case, our theta is 68. Theta of 68 is equal to 22 divided by x, okay? So we have 68, cosine of 68 is equal to 22 divided by x. Now, in order to solve for x here, the way to remember how to do this is when x is in the denominator like this, we have to take the inverse cosine of 68. So I know that sounds a little complicated, but this is basically what we're going to end up doing. X is going to equal 22 times the inverse cosine of 68 degrees. Okay. Excuse me. No, not that. I apologize. Let's. All right. So in order to solve for x here, first thing we want to do is multiply x on both sides. That gets rid of the x, right, on the right side. So now we're going to have x times the cosine of 68 is equal to 22. And the last part, we're going to have to divide both sides by cosine of 68. And when we do that, okay, when you divide both sides by the cosine of 68, all right, I'm just going to erase where I wrote that because I still want to fit this in. So you still need to write that step. And then after that, you should write this. X equals 22 divided by the cosine of 68. Okay, because all we're doing here is dividing both sides by the cosine of 68. So once again, x is equal to 22 divided by the cosine of 68. Okay. And now to get our answer in decimal form, okay, in order to get our answer in decimal form, all right, let's just go back. So at this point, when x is in the denominator like this, when we're solving a fraction, we can go ahead and just write x equals 22 divided by cosine of 68, okay? And then we just need to figure out what that equals. So I'm gonna do 22 divided by, then I'm gonna put parentheses, 68, and then I'm gonna hit cosine. Okay, and then I'm gonna close my parentheses and I'm gonna hit the equal button. So now I know that x is equal to 58.7, because remember they want it to be in tenths, to the nearest tenth. Okay. All right, number 27. Number 27, once again, we've already highlighted the hypotenuse. We need to identify the angle, and now we can identify what's opposite. This is opposite. The 11 is opposite, which makes the blank side the adjacent. Now we're looking, the parts that we have is the opposite and we have the hypotenuse. The adjacent, they didn't give us anything. It's completely blank. So we need to look for the trig function that uses opposite and hypotenuse, which is sine. So this is going to become sine theta is equal to opposite over hypotenuse. And our theta is 39, so sine of 39 degrees is equal to 11 over x, okay? And now that we got that, the x and the sine of 39 are going to change places, so this becomes x is equal to 11 divided by sine of 39 degrees. And then we go over to our calculator. We're going to hit 11 divided by parentheses 39, and then sine, close it, hit equals, and we get a whopping 17.5. Remember, we have to round it to the nearest 10, so this would be 17.5, okay? Final answer. All right, let's take a look at number 28, all right? Number 28, we already have the hypotenuse labeled. Here's our angle. Oops. Here's our angle, x. And now we need to label opposite of x is 28 and adjacent is 19. So they didn't give us anything for the hypotenuse. Hypotenuse is completely blank. What trig function uses opposite and adjacent? That would be tangent. So we're going to be using tangent here, okay? So this would be tan theta is equal to opposite over adjacent. We're going to write tan x is equal to 28 over 19, okay? Next, we know that x is going to be equal to inverse tangent of 28 divided by 19, okay? And now x is equal to, so we have to do, I'm going to hit parentheses, 28 divided by 19, close it, and then I'm going to hit inverse of tan, which is tan to the negative 1. I'm going to hit that button, and now I have my decimal answer, which is 55.8. 55.8. And since x is the degrees, we have to put as an angle measure. Okay, 55.8 degrees. All right, number 29. Here is our angle. Once again, the angle is x. Okay, we need to figure out what's opposite. This is opposite, so that makes the blank side adjacent. We're not using adjacent. We're only using opposite and hypotenuse for 29. So which ones use opposite and hypotenuse? That would be sine. So sine of theta is equal to opposite over hypotenuse. Sine of x is equal to 5 over 16. And now we're going to do x is equal to the inverse sine of 5 over 16, okay? And if you notice, for examples 28 and 29, when x is part of the trig function, when you solve for x, you're going to do the inverse of that trig function with the fraction, whatever the proportion is, okay? So, just wanted to make that clear. But let's go ahead and figure this out. Let's clear that. So first, we're going to do parentheses, 5 divided by 16, close it, and then we're going to hit sine inverse, which is 18.2. So x equals 18.2 degrees. Okay. All right. And 30. Once again, identify x. Identify the angle and then identify the opposite. So that's opposite. This is adjacent. Which trig function uses adjacent and hypotenuse? That would be cosine. So we're going to use cosine of theta is equal to adjacent over hypotenuse. Cosine of x is equal to 24 over 28, which we could reduce that to be 6 over 7, okay? So we're going to do x is equal to cosine inverse of 6 over 7, because I divided both of those by 4, okay? So we're going to clear everything. We're going to do parentheses, 6 divided by 7. Close it, and then I'm going to hit the inverse cosine. So x is equal to 31.0 degrees. Okay. All right. So let me get rid of the calculator for a moment. Let me slide this back over. So what I want to do right now is take you through, just to review this real quick, okay, before we do 31 and 32. All right. Now, so for example, 28, 29, and 30, you see that x was on the same side as the trig function, okay? However, when we solve for x, we had to use the inverse of that function with the fraction. Okay, so that's one thing you want to remember, because some people have a hard time trying to remember how to solve those. All right, so that's one little pattern you want to remember. Now, when x is in the denominator, like these right here, excuse me, if you notice, when we solve for x, the x and the cosine, or the x and the trig function, switch places. Okay, so instead of 22 over x, it was 22 over the cosine of 68. And instead of 11 over x, it was 11 over the sine of 39. Okay, so just showing you those patterns there to help you all, process this information a little easier. All right, let's go ahead and do these last two. Says the angle of elevation from a buoy in the water to the top of a lighthouse is 68 degrees. If the buoy is 300 feet from the base of the lighthouse, find the height of the lighthouse. So let's draw a little lighthouse first. Here's my lighthouse. All right, lighthouse. Boom. And there's a buoy over here in the ocean that is 300 feet away. All right, 300 feet away. And the angle of elevation of the buoy looking back is 68 degrees. Okay. They want us to find the height of the lighthouse, which would be x right here. Okay. So this distance, they want us to find the height of the lighthouse. Okay. So now what we need to do, and remember, here's our right angle. Okay, so we pretty much have our right triangle right here. Okay, and let me move this x to the outside, because x is really a side. They want us to find the height of it. All right, so let's go ahead and label the hypotenuse. Right, hypotenuse is always opposite the right angle. Then here's our angle, our theta. So what's opposite of that? X. So this is opposite, which means that 300 feet is adjacent. Now, the parts of the diagram based on what we drew up and what they gave us, we have O and A. O and A. So O and A is TOA, which is tangent. Okay, so we're going to do tan theta is equal to opposite over adjacent. In this case, it's going to be tan theta, or excuse me, not tan theta, but tangent of 68, right? Tangent 68 degrees is equal to x over 300. Now, to solve for x is going to be equal to 300 times tangent of 68 degrees. So let's use our calculator and figure out what that equals. Okay, so we're gonna do 300 times parentheses 68 tangent, close parentheses, hit enter. So, and we need to round it to the nearest tenth. So our height of the lighthouse is 742.5 feet. Final answer. Okay. All right, number 32. It says a wire is tied from the top of one tower to the top of another. The angle of depression from the top of the taller tower to the top of the shorter tower is 37 degrees. If the wire is 100 feet long, find the distance between the two towers. So let's draw this out. Let's say this is one tower. Here's the other tower. This is obviously the shorter one, okay? And then we have a wire, from the top of one to the top of another. Now, we also have an angle of depression. Now, let me take some time to pause real quick and go over what an angle of depression is. Okay. So, when we're talking about angles, for example, let's say this is the ground. Okay. And this line that I just drew is a wire or a sight. You know, this line here. Okay. Now, elevation, if we have some, let me make some makeshift walls here. Okay. So for example, angle of elevation is if you had, let's say, angle of elevation, okay, is, I don't know, 72 degrees. That goes here. Okay. However, if we had an angle of depression where you're looking down from top to bottom, let's say the angle of depression was, I don't know, 57 degrees. That angle would go here, okay? Not on the inside. So, which means that, for example, if we were just focused only on the angle of elevation, then I would draw my triangle this way, okay? And this would be my right triangle. However, if that's not what we're doing, and I'm using the angle of depression, right? Let's use the red. If I was using the angle of depression, then my right triangle would be this one here, like this, okay? So I just want to make sure that we're clear on how to label an angle of elevation versus an angle of depression. Because sometimes people may make the mistake and put the angle of depression right here, which that's wrong. That is wrong. You can't go there, okay? The angle of depression has to be on the top part of the line. Angle of elevation has to be underneath the line. For example, angle of elevation couldn't be right there, okay? So that would be, this angle of elevation would be wrong, all right? So just want to take time to make sure we're clear on that. So let's go back over to our diagram. So once again, there's a wire. I'm going to use a thinner line. Here's our wire. And it says that the angle of depression, okay, angle of depression from the top of the taller tower to the shorter tower is 37 degrees. So we need to put 37 right here, which means now that our right triangle that we're looking for would go right here. Okay. So if I need to, I'm gonna just kind of draw this again. And let me make sure that we, so I'm gonna draw my triangle like this. Put my right angle here. The wire is 100 feet long. Remember, that's the wire. Excuse me. Once again, the wire is 100 feet long, and I can put that over here, 100 feet. Remember, this is 37 degrees that they gave us, and they want to know, find the distance between the two towers. So the distance that we're looking for is X, right? Because if the distance between the two towers is this distance, then the top of my green line, which would have been right here, right? Here's the green line. And here's the wire. I'm just color coding it just in case some of you all right? So the distance that we're looking for is the distance across between the two towers. So that's how we would label our diagram. Now that we have that, let's go ahead and label the parts of our triangle. This would be our hypotenuse, and then here's our angle, right? So this angle here That's there. This represents opposite, which makes the x the adjacent. So when we're looking at our diagram, the only two parts that we have are A and H, because the opposite, the O, doesn't have anything over there. So the adjacent has an x variable, and the hypotenuse has 100 feet. But we need to figure out which trig function uses opposite and hypotenuse. Excuse me, adjacent and hypotenuse. So if we scroll back up, cosine is adjacent over hypotenuse. So we're going to use c, okay? So cosine, oops, let me write that a little better. Cosine of theta is equal to adjacent over hypotenuse. So we have cosine of 37 degrees is equal to x over 100. So that means that now x is really equal to 100 times the cosine of 37 degrees. So now we just need to figure out what that is. And we're going to round it. Does it say round? Let's see. Oh, round all our answers to the nearest 10th. So once again, we got to round it to the nearest 10th. So let's pull out our calculator. Oops. Hold on. Let me pull it out the right way. There we go. All right. So in the calculator, let's clear this. Make sure we're in degrees. I'm in degrees. I'm going to do 100 times parentheses. Then I'm going to hit 37. Then I'm going to hit sine. I'm going to close the parentheses and hit equals. So now we have the answer here. Oops, not sine. Sorry. I put the wrong trig function. Let me try that again. So 100 times, where's my multiplication? Times, and then parentheses, 37, and then I need to hit cosine, not sine, cosine. And I'm gonna close my parentheses and hit equals. And now we have the correct distance between the two buildings, which is 79.9, because remember we got to round to the nearest 10. So this would be 79.9 feet between the two buildings. All right, ladies and gentlemen, that will conclude our lesson today on the use of trig functions to solve right triangles. You all have a great day, and I'll see you all back for another video.